Hey guys, and welcome to this tutorial. And today I'll be showing you how to write a simple neural network that will learn the XOR operation. So what is the XOR operation? Well, the XOR operation is exclusive OR. Basically says if given inputs of like 0, 0, the output should be 0. But if the input's like 0, 1, then the output's 1, 1, 0, 1, and then 1, 1, 0. So obviously you don't need to write a neural network to be able to figure this out. This is just basic logic, but um, it's kind of like a hello world tutorial. So let's get started. So I'll be using this module called Keras. And Keras is really great for prototyping, building, training your own neural network. You can add as many layers with as many neurons as you want, and it uses TensorFlow or Theano as a backend, and I'll be using TensorFlow as a backend for this tutorial. So if you don't have Keras already, you can just go and just type pip install Keras, and it'll download Keras for you. So let's get started. First thing, obviously, Keras uses NumPy. It uses NumPy arrays to as inputs, and it produces NumPy arrays as outputs. So you gotta import NumPy. Then you gotta import the sequential model is what we'll be using. From Keras. Whoops. Okay, so now it's using the TensorFlow backend, and then we gotta import the dense from layers. Okay, so dense is what allows us to actually build each layer. Now, let's make our training set. So this is basically the XOR. So here I'm going to have 0, 0, 1, 0, 0, 1, and 1, 1. Cool. So that's our input, and then the desired output will be another NumPy array. The first one will be 0. Oops. Next one will be 1, 1, 0. And we're okay, good. So X, Y. Okay, that looks good. Now, let's actually start building our neural network now. So I'm going to get our model is equal to. So we're just saying that we're just first starting with a blank model, and now we're going to start adding in our layers. So I played with this, and I found that the certain model I'll make now works pretty well. So just watch, and then I'll explain. Why the code is the way it is after that. So we're gonna add dense. First that'll be 10. Yeah, one extra parentheses. Okay. Cool. And I messed something up. What did I do wrong? Oh my. Alright, my bad. That's why it went off. Spelled input wrong. Okay. Okay, now that's our first layer. Let's add our second layer now. Sorry for that wait time. I want to make sure I spell everything correctly. This is going to be our final layer. Nice. So we built this model, and again, apologize for that wait time. I didn't see I spelled input with the M instead. But what is this model like? How does it look like? And what are all the parameters when calling dents? So if I quickly open Sketchpad, so our inputs are going to be 0, 0, 0, 1, 1, 0, 1, 1. So that's our possible inputs. And each single input has a dimension of 2, right? Because there's 2 different variables to it. So when we first called our first layer to have 10 and input dimension 2, that means what it has is these 2 inputs, and then it's going to have 10 neurons in that layer. I'm just going to do dot dot dot. So this is 0, this would be 9. If I can draw properly. So imagine 10 neurons here, right? And then it's all going to be connected neuron to each one, like so. Like that. And then we have another layer, 6 neurons, so again, dot, dot, dot. And then imagine that's all interconnected like this. You get the point. And then finally, we have this final layer with 1 neuron. And then this produces our output. So what does this thing called activation mean? Well, there's many different types of activation functions that each neuron performs. They're all different, and for what I did to choose the ones that I did for each layer, it was kind of just a trial and error, and then I picked the best one. So here's the model that we just constructed. So for example, it'll take a 0 input, 0, 1, and then it gets passed through the weights, activation, some output, and then it's over time. We will now need to train this model so it actually gets accurate. Because at first it just starts with all random weights, and it'll produce not accurate results. So since we built our model, what we'll need to do is compile it. think that's it. Good. And now let's train our model. So, how to train it? We do model.fit. So that's our input and our desired output. There's something called epoch. And what that means is, how many times do I need to keep on cycling through our training set? And you can specify that. Obviously, going through 10 times will not be very effective. But for now, let's just go to 500 times. And then batch size. That just means how much of our training data do we want to pass through to train, right? So if we specify that it's one, it's just going to be one training set, one training data. It gets passed through at a time. So let's run this. Depending on how fast your computer is, it'll take that much time. It's froze right now, but I think now it's done. So let's observe this loss. So loss means how inaccurate it is. So obviously, the smaller loss gets, the better. And as you can see, loss gets very small. And now let's actually test our model. So model.predict. Let's create a tiny array. Let's just say 0, 1. And it predicted that it's basically saying 1. Let's try that again. What if we make this 0? Now it should be very close to 0. Correct. Oh. Yeah, so that one, even though it's kind of close to 0, it's not very close to 0. If I trained it more, it probably would have been better, but still. Yielding pretty good results. So that's it. Obviously, as the creator of Keras said, whose name is Francois Cholet, using Keras to solve the XOR problem is like cooking a grilled cheese sandwich with a rocket engine, but I believe it still provides new users a pretty good understanding on how it works, so you can build more complicated stuff. So thanks for watching, stay tuned, and feel free to ask any questions below.